Hello everyone and welcome to this GeoTime webinar. Today's webinar is Cycling Data in Newcastle upon Tyne. I'm Curtis Garton, the Visual Analytics Product Manager here at ArcGIS. I'd like to give you a brief introduction of ArcGIS before we jump into our main presentation. At any point during the presentation, you can type in questions in the lower left-hand chat window. A little bit about ArcGIS. ArcGIS is a company that's obsessed with visualization. We focus on the science of visual analytics. Some of the areas that we focus on are defense intelligence, finance, GIS, risk analysis, as well as open source intelligence. All of these different areas have a common problem, which is they deal with a tremendous amount of complex data sets that make it difficult for leadership and decision makers to make decisions. Our customer sets fall into a number of different categories, including defense, public safety, law enforcement, as well as finance. ArcGIS recently introduced our new data analysis services. These services are geared towards helping organizations and companies to analyze complex data sets. Our focus is on the analysis of this data visually. The result of our analysis work is presentation and reporting material. Some of the different organizations that we work with on a day-to-day basis. Some of the different projects that we've been involved with, including the vast competition. To give you an example of how ArcGIS approaches problems, I'd like to walk you through a simple example. The problem of how do you look and analyze movement data. This is a really complex problem when you really pull into the complex data sets that you're going to be dealing with when you're looking at movement data. Traditionally, we look at movement data on a map. Here are points on the map of North America. Each one of these points represents a moment in time where an individual has been. If we were to connect these points together, we could see the order of them. But this does not help us in understanding the movement. ArcGIS came up with a novel solution of introducing an animated timeline. This timeline as the third dimension allows us to see the movement over time. We can actually see the sequence of events that makes up movement. This allows us to do things like spot patterns, trends, and exceptions. We've incorporated that into a product called GeoTime, which aids in looking at movement, temporal, and link analysis. Some of the different areas that GeoTime has been used includes GPS and movement data, crime report analysis, communications analysis, as well as financial and social network analysis. That's a little bit of an overview on GeoTime. I'd like to now hand it over to Dr. Seraphim Alvanides, as well as Godwin Yeboah, who are going to be giving you the main presentation.
Thank you for the introduction, Curtis. This is Seraphim Alvanides from Northumbria University, and I have with me Godwin Yeboah as well. So we're going to go through this presentation. First of all, a short interview. I'm going to explain the inspiration behind this study. Then we're going to explain some definitions or discuss some definitions and how they link to Godwin's PhD research. Godwin is going to expand a bit more about the technicalities of the specific research, which is about cyclists and how they move in the city, in a city like Newcastle upon Tyne, the kind of GPS devices we used, how we collected the data, how we cleaned the data, and he's going to focus then on the use of GeoTime mainly for editing and cleaning the data at this stage, before moving on to some ideas about analysis that we want to take forward. And finally, we're going to conclude this research and give some ideas of further directions that we would like to take it to. So the inspiration behind this research, which is mainly about cycling and the call of using active travel in daily mobilities, came when I was doing this project in Newcastle upon Tyne. You can see on the upper right map in relation to the UK. This is a Scottish border. So Newcastle is quite a northern city in England. It's probably the last large city before the Scottish border on the east side. And what we were looking at was children's mobilities to school, so where children live and where they go to school. And what we were expecting to find was that children go to the nearest school. This was primary school children and secondary, so ages between around 6 to around, let's say, 14, 15. And so what we were expecting to find was that children go to their nearest school. In reality, what we saw, once we mapped the data using postcodes, of course anonymized for data confidentiality concerns, etc., was that the pattern underlying the data set are these blue magenta lines which show where students or pupils live and where they go to school. And then I did some further analysis trying to understand what would happen if they were to go to the nearest school. So the centers of these spider graphs are actually schools, and these are the locations of the pupils if they were to go to their nearest school. So the reality is very different to what we hypothesized. And this was a starting point to make us think, if this is what happens, so the children not going to the nearest school, then it's very difficult to implement ideas like convincing or encouraging people to walk or to cycle to school, because the distances here are much larger. The next step was to try to understand this a little bit more by using sort of space-time mapping. So what we did as part of this British Academy funded project was to trace the movements of 17 households, and that was quite a few years ago. So we didn't use GPS devices. We were asking people for postcodes, where they work, where they go to school, or where they live, and we tried to map this information. And then it took me ages, of course, to convert this into some sort of space-time three-dimensional map. And these are the patterns that were shown. So what this map shows is actually that the school choice is part of a complex space-time negotiation between household members within the family. So we color-coded them based on gender here, and the blue lines are the mothers, the women in the household. Some of them are single mothers, and the red lines are the fathers. We had fewer fathers taking part, but the pattern becomes quite clear here that the fathers tend to have a simpler space-time diagram and daily mobilities compared to the mothers in our sample. But the bottom line of this research was that people have complex lives, and if you want to encourage them to be more physically active by using public transport or walking or cycling rather than relying on cars, you have to think very carefully about how people negotiate their space and time requirements. So some definitions then in relation to the specific project. We focused on cycling because the combination of cycling and walking is making it a bit difficult to track for during the course of a PhD thesis. So utility cycling in this context is cycling done for fitness, recreation, such as, not done for fitness or recreation, such as touring or sport. So it is cycling as a means of transport or travel by adults and of course their children. And the adults here in our sample, so we didn't use children for our sample, is defined as cyclists above 19 years old. Active transport in the literature is a form of travel where there's human muscle involved during the process, so it's walking or cycling or even taking public transport because it also involves an element of walking or cycling. Obviously, driving a car involves some human muscle, but not to the extent that walking or cycling involves it. And then finally, the cycle trip for our study is a journey by an adult cyclist, and it's bounded by stops, and you can identify it within a travel diary. So it has clear purpose and origin and destination. That's what we call a cycle trip. Why cycling? Why are we so obsessed with cycling? Well, first of all, In the context of reduced resources of the planet and making an effort to for sustainable development and sustainable livelihoods, cycling is the answer to some of the problems like traffic congestion, increasing population in cities, etc. The second one is in relation to health and more healthy living. So cycling has been promoted for its health benefits. And in terms of how do we understand cycling, there's various approaches from ethnologic and very sociological to more kind of quantitative approaches about trying to understand why cyclists take specific routes and whether there's any way we can model this process. So I'm going to hand over now to Godwin, who will explain the background of his PhD research.
Okay, thank you, Seraphim, and greetings to all of you. My PhD research is entitled Constraints and Enablers for Cycling in Urban Environments, an integrated model approach. The research is aiming to address the question, does the built environment constrain or support urban cycling? And if yes, how? It therefore hypothesizes that the built environment can constrain or encourage cycling behaviors. One of the objectives is to collect primary data on cyclist perception and experiences. Of course, there are others, but just for the sake of time, I opt for just one. The supervision team is made up of Dr. Seraphim Alvanides and Dr. Imani Thompson, and the work is being sponsored by Northumbria University. What you see is the study area which is around Tyne site conurbation in the northeastern part of England. The green and the blue dots show some of the homework or school locations of participants. Despite the policy initiatives by the Newcastle City Council towards promoting lower carbon methods of travel, there appears to be some dissatisfaction from local campaign groups about the lack of coherent cycling strategy, negative attitudes towards cyclists, slow rate of cycling infrastructure provision, even refusal of the local public transport providers to allow bicycles on the metro system. Interestingly, the metro in the area is now owned by Deutsche Bahn, a German company which allows bikes on the metro in Germany, I mean, as I have witnessed myself. But interestingly, in Newcastle, it appears not so. And also integrating cycling as a means of transport rather than only focusing on leisure activities. Based on lessons learned from related studies in published literature, such as Department for Transport GPS feasibility study and TU Delft study shown here, I initially targeted a sample size of 100 cyclists, but eventually had 118 people who initially agreed to participate. So as you see, there are 111 cyclists qualified after the screening based on mainly utility cycling definition and the possibility of getting VR traces within the study area. I will talk about the fieldwork process in the next slide, but in all, 81 cyclists participated, and data from 76 is being used for this presentation. The fieldwork was undertaken in 5 main stages: the planning and preparation phase or stage, invitation stage, screening, recruitment, and then data collection stage. So as you see there, for the planning and preparation phase, it actually comprised of the preparation of materials such as online questionnaires using SurveyMonkey's web services and setting up Twitter account. Preparation of offline questionnaires covered the travel diary, flyer, brochure, poster for notice boards, email content, email list request applications, among others. The next stage, that is the invitation stage, it involved tasks such as sending emails to about 350 potential participants, placing posters on notice boards, handing over flyers, brochures at cycling events, and creating online awareness using Twitter, Northumbria Community News Online, SurveyMonkey, among others. As indicated earlier, the screening stage was mainly based on the definition of utility cycling and the possibility of getting participants GPS traces within the study area. The recruitment stage covered face-to-face meeting with participants, introducing and handing over GPS device with travel diary and questionnaire form. During the actual data collection, participants carried GPS device and filled travel diary for a period of 1 week. They also filled other forms only on first and last days of survey week. Participants were introduced to the basic use of the GPS as shown with additional test information in a leaflet form. They were advised to place the device in the top compartment of their bag, for example, as you see there, or in their pocket or on a key ring. This shows the interface for configuration of the GPS device. The GPS device is configured to log at 5 seconds interval and records time, coordinates of points along path of travel, speed of travel, dilution of precision, number of satellites at time of recording, and distance of travel. This shows an example of 1 week raw data of a participant. Given the level of scale, one may see it as messy or not. In our case, we see it as messy, and a typical example is shown in the next slide. As you can see here, actually, that's the messiness we are trying to say. And the next slide actually shows this kind of example. As a way of cleaning this messiness or noise in the data, I introduced space-time cube-based data cleaning approach using GeoTime. So the approach is basically, this shows the workflow itself. In this approach, the raw GPS data is loaded into the space-time cube in GeoTime. And the secondary data such as OpenStreetMap with the travel diary are used to assist in visual inspection and decision making regarding which part of the GPS data is redundant and need to be removed. I'll show you this in the demo. But for now, this is a typical example of what I just described. Redundant point sets at the trip ends are removed as a way of refining point sets defining the cycle trip. So let's just go to the demo, and then I'll talk you through. So I have here the raw data and then the travel diary. And I've loaded already it inside the ArcGIS suite, ArcMap. And what you see at the background is the OpenStreetMap. So now I send it through ArcMap to GeoTime. And here, for GeoTime to understand the raw data, it needs to map it. So this is actually showing the map. And in GeoTime, you have to make sure the data format, or the date format, or the time format, as recorded or as in the raw data is exactly as GeoTime will see it. So you can see here the table and in a way judge whether it's correct or not. And then here I'm allowing GeoTime to import the data. So this is the raw data and gives some little bit of summary about this. So what you see is the raw data, and now the issue is to refine it in a way such that it can be used for further analysis. So here you can use this temporal axis to map this point sets to the OpenStreetMap, that is if you want to see something. But at the goal, you can actually see on the calendar in GeoTime the amount of travels or trips done per day, for example, because this was given per week. The data is covering per week, covering a week actually. So, and that's what you see here. The next is just to be sure of the orientation. You can compare this with ArcMap. That's what I'm trying to do here. So you flip to ArcMap and then you see the orientation visually, and then just ready to be sure the orientation is correct. Okay, so now I go to the travel diary and look for a trip. So I look for maybe the first day of the week as started by the participant. And as you see here, that is the first trip, journey 1, the time, the start time, end time, and then you have the mode showing that it's a bike trip, or for example, in that mode. So in that case, I pick that date, then look for that trip, and it's the first trip. So I just, this is for the day on the 9th of November, this is the entire trip made. So I pick the first trip, and then zoom in, and then try to inspect whether that trip is okay or needs some kind of cleaning. So I look at the time again, and you see it ends somewhere around 9 o'clock, but it goes far as 11 o'clock. So based on inspection, you could see that this point set expanding from somewhere around 9 to 11 might be really redundant. So that's what I'm, based on my discretion and then my inspection in the diary, that's what I'm trying to judge and clean. So I cleared some part and just want to be sure the other part, and you see a gap here. So actually it gives that indication that actually the person stopped, and this is just the device either in the pocket or just lying somewhere. So I'll actually remove some of the pointers as shown at the background, and then try and refine it. So you see this pointers here just below the Devonshire building actually is redundant, because the person actually indicated that it ends around the Devonshire Terrace, not to that extent of the building where you have the Great North Museum. And also this GeoTime allows the possibility of visualizing all the attributes of each point. So if, for example, you are inspecting the pointers and you are in doubt, you can actually visualize all the attributes, especially in terms of the dilution of precision parameters, to judge whether actually it's a good fix or not, or it's a quality point or not. And so the background actually also helps, that is the OpenStreetMap helps in giving this judgment. So what you see here is actually the refined data, as you could have seen previously, and this is more of a refined data, and in a way it reduces the memory usage, and it also helps in further analysis, knowing very well that if you've removed data that's not needed. So I have here some of the links that you can go to, but we can continue with the presentation.
All right.
Okay, I think let me just end. Okay, I'll continue here, and then Seraphim will come in very soon later. But so what else can be said? Assuming, let me go back to this one. Assuming space-time cube applicability entails these 3 stages to realize its full potential usability cycle, then it is fair to argue that the shown kind of cleaning approach fills a gap and completes the cycle. That's what I'm trying to argue here. The average time spent on cleaning the GPS tracks using this approach is about 7 minutes. So at this stage, I will invite Seraphim to continue from here, and we'll come in later at the end. Thank you.
Right. Sorry about earlier. So this is the cleaned data set. The colors here are not significant. It's just different participants. So I'm going to give you a couple of examples of where we're planning to take this research forward, how we're planning to do this. So through this process of cleaning the data, Godwin managed to clean 907 cycle trips based on the definition we gave earlier, with very clear origin destination for 76 participants. This is a split by gender, and immediately you can see how we can test the first hypothesis that women tend to cycle shorter distances compared to men. So we have here the minimum and maximum distances. The maximum distances tend to be shorter for women, and also in terms of kilometers per person. And they also do they cycle shorter trips. And of course, what is very interesting then is to visualize this kind of information in both space and time. And what we have here is the women in red and the men in blue. And you can see visually the summary results that I presented earlier. So this is how we now start testing various hypotheses from the literature, but having a very solid and clean data set. Another argument, as I showed in the very beginning with the inspiration of some of this research, is about when do people actually do their cycling. So given that we're focusing on commuting cycling and functional cycling, especially in relation from home to work, which is what this subset of the data set is about, we can see whether people cycle within the cycling network or off the cycling network. There are some gaps in the cycling network, like in most cities. So if you want to go from A to B, there is no guarantee that you can complete a whole trip on the cycling network. You may have to occasionally go off the network and into motorway, well, not motorways, but kind of busy bus routes, etc. So this is the kind of information hypothesis we're trying to test here, depending on the time of the day, and also for the purpose of the trip. The purpose is home to work for all the trips, and whether people are cycling off or on the network. So for long distances, people tend to prefer the safety of the cycling network, but for some areas within the city, shorter trips, shorter distances, they go off the network, maybe because the network is not adequate, or it's not the fastest way or the most straightforward way to connect the origin and destination. And talking about origin destinations, we can also identify, based on the flow of the cycling, whether it's from or to work or home, we can identify the centers, the origins and destinations that people tend to visit, and try and do some sort of space-time cluster analysis, like in this example. So here we're trying to find stops where there's at least 10 of these stops grouped together within 8 kilometers and within 30 minutes at the same time, and trying to understand where the cyclists tend to gather, not on purpose, but what sort of activities in the city center would encourage people to cycle more to get to these destinations. So just to try and bring this together then, we try to focus on this idea of the space-time cube for the data processing and editing, rather than taking it forward for analysis, which is going to be a future presentation, because we do find that it's a useful tool visually and intuitively when we're trying to clean some of these messy GPS data sets and tracks. However, this approach is quite limited unless you have travel diaries, as Godwin showed earlier, the anonymized handwritten travel diaries that give further information about the purpose of the trip and the origin and destination. And also, it's necessary to have base maps to try and understand how the route choice has worked out. So obviously, if you see a track inside buildings and someone says that they're cycling, it means there's something wrong there in terms of either the GPS tracker or the way that people recorded the time. And the clean data then that we showed earlier can also be used for comparisons with algorithmic results. There's a push for algorithms to clean the data automatically and present the data, but they haven't been tested extensively yet. And also the space-time analysis obviously can provide insights in terms of differences and different cycling behaviors and the usage of the cycling network, which is the core substantive element of this research. So one idea that could help, one recommendation for improving this space-time cube approach in terms of cycling and better connection with the GIS is to be able to export the cleaned point data set into polylines from GeoTime, for example, for further analysis.
Okay, thank you, Seraphim. So as part of further work, we hope to explore the collected data alongside Tyne and Where travel survey data and other data that we will find available. Also, considering other functionalities that GeoTime offers, we hope to explore the best ways of visualizing the data, as well as reconstructing cyclist travel behavior using agent-based modeling and simulation techniques. Please allow me to thank GeoTime for providing the software and the special license for this research. I will also want to extend my appreciation to all anonymous participants for their immense support and encouragement in terms of the data collection, and even beyond that. And thank you also for attending this webinar. The next slide shows some of our links if you want to contact us. And thank you.